All right, so welcome everyone. Today is day 7, and we are starting off with lesson 3. Lesson 3 is about machine learning on Google Cloud. All right, so we'll be looking at machine learning on Google Cloud through the lens of the professional machine learning engineer certification journey. Um, so the idea here is choice. Right? So Google has a lot of multiple machine learning parts, machine learning offerings, depending on effort, expertise, and how much control you need. So most of the times, the questions you're going to be seeing are, they want to know, do you know the right tool to use that meets the business requirements with probably the least effort, or probably that meets the expertise, all right, or meets their needs. If they need more control, do you know the right tool to use? If they don't need control, they just need something fast, do you know the right tool to choose? And so that's what we're looking at here. But before we proceed, the question you should have in mind is, what is the simplest option that still meets the business requirements? All right, so which option is it? The simplest option that still meets the business requirements. That should be the key to answering the questions. So if you have a more complex solution and you have a simple solution that meets the keyword here is the solution should meet the business requirements. Once the business requirement is met and the option is simple, go for the simple one than going for the complex one, even if both meet the business requirements. Always go for the simplest solution. So that's what we're looking at today. So before we go dive in, how many of us have built a model before? How many of us have built a model, trained a model? Let me see your reactions. If you've built a model before, even if it's on notebook, even if you just on your notebook or Jupyter notebook, you train the model, or let me see your hands. Okay, or you can write it on the chat. Just want reactions. Okay. Now, when you hear production, production ML, what comes to your mind? Yeah, on cargo. Yeah, good. Very good. Taxi model, taxi fare model lab on BigQuery. Very good. Yeah, BigQuery ML. Good, good, good. Yeah. So now some of us have had experience with building models. Now, what comes to your mind when you have machine learning, production machine learning? The deployment, monitoring, production machine learning, is it deployment, monitoring, data pipelines, or all of the above? Um, so just have that in mind. What comes to your mind? Of course, that's what we are looking at. Um, so our journey today will be very, very, very simple. We'll be looking at the options on Google Cloud, compare them, and then practice identifying the best option for a scenario. So we're looking at the pre-trained APIs, the training models. These are different options on Google Cloud. Whether we have to use, in order to train a model, see why I asked the question, you might have option of using, or in order to solve your problem, you may have to use a pre-trained API just for your solution. You might need to train a model, or you might need to use BigQuery ML to train the model, or you want to use BigQuery ML, right, or AutoML, or do a custom training. So these are different options we're going to be looking at, and then we'll be knowing which one should we go for, given the circumstances. Okay. Now let me ask, what's the biggest struggle right now? Is it choosing tools, the correct tools, or understanding the machine learning operations needed, or you're concerned about just knowing what Google wants in exam answers? What's the biggest challenge struggle right now? What, just put it in chat. Are you more interested in knowing which tools, choosing the right tools, or understanding the machine learning operations, or knowing the correct answers that Google wants in exam? Just put it in chat for me. So let's look at let's look at the options, different options. So we have so you can see from the left to right, left to right, we have the pre-configured, this one's already pre-configured, APIs that we can call to do a number of things. We can call an API that will do sentiment analysis, all right? And then you now have, in the middle, you have offerings that require low code or no code even, like the AutoML, you might not need to code, just give it the data, then it does everything for you. And then BigQuery ML might just have little code to all train the model. And then if you want full control of everything, you want to have your customized libraries, everything you can do it yourself and do your custom training, fine tune and everything, put your parameters, hyperparameters. So this is the level. You can see the complexity from here. Simple, least effort, but everything is pre-configured, no control. And to the part where you do everything yourself and you have full control. All right, then in the middle you have, little or no code solutions. All right, so now, yeah. So we've seen the different offerings, and of course, with the pre-trained API, you have the fastest minimal machine learning work to do. And for BigQuery is usually SQL first. Your data stays in BigQuery. If you don't want to move it around, SQL first, then you go for that. And then if you want a minimal code, and Google does a lot of tuning, you use AutoML. And then if you want maximum control, yes, so, all right. So for instance, you want to do sentiment analysis, you might just decide to use API straight up or we might have to start training a model for sentiment analysis. And yes, so let me give you an instance right now. This is a model on, no, sorry. This is a model this is a model on Hugging Face for sentiment analysis, right? So I fine-tuned the BERT model, and yeah, I fine-tuned the BERT model. The base model is the BERT based on case, fine-tuned it, and used the custom PyTorch, to do it. At the end of the day, been able to use the model is here on the spaces here. Let me click on it. Live demo on Hugging Face Spaces. So you can see this model can do sentiment analysis here. You can upload bunch of, there's a whole lot of work that has to go into you training the model and then using it to do sentiment analysis. So let me just give us an instance. Let's say I am happy. And let's predict the sentiment. It tells you, oh, sentiment is positive, 99.5, 99.59, confident that this is happy. I'm happy, but sad. Let us try to confuse it and see what I know. It's negative. Totally trying to see. We could see the sentiment analysis, or we could just go ahead and use the Google Cloud API for sentiment analysis. So which we are going to see later on. Now, let's compare these different options. All right, so we have the pre-trained. We've seen this already. BigQuery, AutoML, and custom training. Now, there are a lot of criteria here, dimensions here. The time to train the model, the flexibility to tune the hyperparameters, the coding expertise of the team, the data size involved, the data type. So these are questions you're going to be saying. So if you say that if in the question tells you that the data is tabular data, first thing that comes to your head, just know that is BigQuery BigQuery ML. Okay, it's likely to be okay. Sorry, tabular data. Of course, these other ones also take tabular data, right? So, but if it's tabular data only, if the system only accepts tabular data, just know that it's BigQuery ML. So these other ones, now, if they tell you that the team requires have no coding expertise, right? There's no how they will doing a custom training because the team has no machine learning and coding expertise. They can't be doing custom training with no coding expertise. All right, but they can do AutoML and probably use a pre-trained, right? Or if the question says they have medium to low, then you just know that it falls between pre-trained, BigQuery, and AutoML, and they rule out custom training outrightly from your answers. All right, so we see here the training data size here, no data required, and medium to large data is required. So if in the question you're saying the data size is small to medium, you just know that it's outside this scope of, okay, small to medium, then that means you should be looking at something within that falls within this range, okay? Yes. But if it is medium to large, just know that you wouldn't be you can't use this. You can't be using a pre-trained when it has medium to large, right? And if they tell you that the latter data set is very large, very, very large, then you might have to rule out AutoML and then start considering BigQuery because it can accommodate medium to large data set. But this accommodates small to medium. So anything above medium, you might have to leave BigQuery and then go for do your custom training or probably use BigQuery ML as the case might be. All right, so when you look at this column here, just know that it's about speed and about simplicity. They want something fast, no data required, no customization. You're not tuning the hyperparameters. There is no time. You don't want to spend any time training the model. Just go for your pre-trained API. There are a number of APIs there. There's Cloud Vision API. There's a number of APIs we're going to see later on. And yes, and then if the data is already in the BigQuery, and then someone has a strong SQL expertise, then BigQuery will be the best option actually because there's someone who knows SQL, there's a strong knowledge of SQL, and then you don't want to move the data around, then BigQuery could be the best option. All right, so you see there's medium expertise with coding, flexibility with hyperparameters, medium, time to train is medium, you don't need so much time to do that, and everything is just medium to large. All right, AutoML will win when you want a strong model, but you want a very good model, but the expertise is for coding is low, right? So in fact, once the expertise for coding is low, just know that there's AutoML and pre-trained, Yeah. So AutoML allows you to do what to just give the data sets to the AutoML, and then the Google Cloud does the rest. Okay. Custom training, you do your own training, ingest the data sets, fine tune, add your hyperparameters. So the team has to have high coding expertise. You have flexibility to change your own hyperparameters, and then it takes a longer time to train the model. Okay. So which option scares you the most? If you're asked to choose, which dimension will you go for? Or custom? Custom scares you the most. Okay. So if you have these three options, which one will you go for at the very instance? Yes. Which option will you go for? If you have these three options, you're told to train a model that um does what? That would predict the number of persons that will come attend the lectures. If you're asked to be able to write a prediction algorithm, yes, I prefer BigQuery ML. Okay, and maybe Auto ML. I haven't tried it. Okay, yeah, we shall see. All right, so now let's see. So these are considerations we have to make. Um, Now let's look at the right option for us. So we're looking at the business need. So when you're choosing the right option, consider the business need. What does the business want? Right? What do they want? First of all, then the skill set of the team, and then the budget. How much is involved? Which one is cost effective? What's the budget? All right, then you now choose the best option for them. So if there is little or no machine learning expertise, there's no little or no intention to train a model. You don't want to train a model. Once in the question you see that there's no intention to train a model, did I went off a bit? All right. So if someone is familiar with SQL and have data in BigQuery, then if the data is in BigQuery already and there's familiarity with SQL, go for BigQuery ML. Right? And then if you want to build custom models with your own training data, custom models with your own training that with minimal coding. So you want to train on your data but avoid heavy coding, use AutoML. If you want full control of the machine learning workflow, end-to-end machine learning, you're going to be doing custom training. Right? Now let's look at pre-trained APIs. Right, so we've seen we already know that pre-trained API does not require training data because it has been trained already by Google, and with the best of their models, they're giving you the best of what they have, and then they're making that model available to you through an application programming interface, which is the API. So all you just need to do is to call the API, and it just basically accepts input, and then you just give it input, it gives you an output. One way in, one way out. So this will save you time and effort. You're not going to building data sets. You're not creating data sets. You're not training any data set. So it's just offered as what services, right? So you can call an API, get prediction without training a model, all right? Have you seen, there's chatbots, translation, moderation, like the way we are doing here, we're trying to record and do translation, transcripts. There's an API that's doing that for us. Or trying to translate a language to another language. You can use translation API. So now let's look at the various APIs that are available, right? And so the number of APIs that are available. There is the Cloud Natural Language API, which allows us to it has natural language capabilities. Those allows us to do sentiment analysis or entity recognition. You can recognize entities, and or do sentiment analysis. All right. You can also tell you that yeah, sentiment analysis, entity recognition, the Cloud Natural Language API does that for us. And another one is the Cloud Speech to Text used for audio to text. Yeah, this is also good for transcribing things, audio to text. Then you have the Cloud Translation API that can convert text from one language to another. We have the Cloud Vision API that's used for vision. We also have video intelligence, and there's the Vertex AI Vision solution. Depending on the scenario. And then we also have the conversational interfaces, which is we can use this API to build conversational interfaces. Use the Cloud Vision Intelligence to recognize motion and action in the video. Right? We shall see that you can actually use, and there's an API that Google has that is used to count number of vehicles or number of persons in a room, or in a place. So, which is also which can be part of the Cloud Vision API. Yes, works with and recognizing content in static images. Yeah, so you can transcribe calls using the APIs, translate documents, extract entities from reviews. We can detect objects and images. That'll be the Cloud Vision API. All right. So now let's the questions are coming early today. So let's see how far we can cover. Now let's look at this scenario. You work for a multinational organization that has recently begun operations in Spain. Teams within your organization need to work on various Spanish documents, such as business, legal, finance. You want to use machine learning to help your organization get accurate translation with least effort. So your organization does not require document-specific jargons. So now this will tell you that they don't need any customization. They don't require domain-specific jargons, right? So what works without special customization? We want it very fast, least effort, quickly. And the translation has to be accurate. That is the business need. We just want a translation that is accurate. And we just want something with the least effort. All right. So what do we go for? So what's the answer? What do you think should be the answer? Please write it in the chat for us, please. Yes. So option A, create Vertex AI workbench in notebook, extract sentence from documents and train um, extract sentences from documents. You can see that A requires custom machine learning work. I mean, we are trying custom auto ML to train. We don't need that. They don't need that. B, the same thing. They don't need a custom machine learning. Yeah. So the answer. So you go with C, right? Now, why is it C? And now let's look at D2. D2 is also unnecessary custom work. See, oh, they are all custom. So this rules out. So the right answer is D, is C, right? C. So use the document translation feature of Google Cloud Translation API to translate. Good. So we understand that. Any question at this point in time? So we all agree that the answer is C, right? So we proceed. Now, you work for an organization that maintains a cloud-based communication platform that integrates conventional chat, video, voice conferencing into one platform. Audio recordings are stored in Google Cloud storage. All recordings have 8 kilohertz sample rate and are more than 1 minute long. You need to implement a new feature in the platform that will automatically transcribe voice, see, voice call recordings into text for future applications, such as call summarization and sentiment analysis. You want to transcribe recording to text, all right? How would you implement the voice transcription feature following Google recommended best practices? Yes, what would you choose? Yes. Any suggestion? Please, if you want to talk, you could mute yourself. Now, A uses C or B. Okay, B. Okay. Okay. So you can see A and B is very similar, but one different. One is synchronous, one is asynchronous. All right. So what is synchronous and asynchronous? So what's the difference? So in synchronous tasks, tasks execute one after the other. File A loads, then file B. So I mean, then that would not be okay for a to transcribe audio to speech. But if we do asynchronous, multiple tasks can be initiated and then run concurrently without waiting. All right, so this is non-blocking. So so synchronous would work with live interaction so that phone call, I mean voice chats. But in this case, we want to do um want to do what? What are we doing? We are sampling the audio, transcribing audio to which I mean this is always better than asynchronous. All right, so the correct option here is B. All right, let's not waste time on that. And so remember, files are in cloud storage, all right, and longer than 1 minute. So that's common trigger for asynchronous recognition. So there's what's called long running recognition. I mean, so there's no requirements about sampling the 8 kilohertz. There's no requirement to upsample, right? Good. So we just take it the way it is. They didn't say upsample. There was no requirement to upsample anything. So that's why we just have to take off this C and D completely. All right. Um, A uses synchronous recognition, which is not ideal for longer audio and operational based service. All right. Good. And then C and D, we're not doing any upsampling, so it's pointless. Right? So the best is async, because it's stored in Google Cloud. We don't want delay. We want something that's fast, and this is lost. It's more than 1 minute long. All the recordings are more than 1 minute, so we don't want it um to wait completely for it before we move to the next. Want more something that's more effective, scalable. All right, so let's proceed to the next question. Any question at this point? So we'll answer a number of questions and then let's see how many questions we can cover today. So you work for a hotel and have a data set. So you work for a hotel and have a data set that contains customers' written comments scanned from paper-based customer feedback forms stored in PDF files. Every form has the same layout. You need to quickly predict the overall satisfaction score for the customer comment on each form. How would you accomplish this task? You work for hotel, data set contains scanned in paper, stored in PDF file. Every form has the same layout. You want to quickly predict quickly, right? How would you accomplish this task? So do we use Vision API to pass the text from each PDF, then use the natural language API to analyze, or do we, which option do you think is it? Do we use the Vision API to pass the text from each PDF, then use, so this is almost the same, but analyze sentiment feature. This one is analyzing what? Entity. What's the question? The question says we should do what? Satisfaction score. Satisfaction score would be a sentiment analysis, right? Not entity. We're not analyzing entity. So this would tell us that this B will not be an option. And so this D also will not be an option because it has to do with entity. So we are now left to uptrain a document AI extractor to pass. So why do we have to uptrain? Okay. So Yes, what do you think should be the answer? So we are left with either option A or option C, because they are the two that does sentiment analysis, right? Now, the constraint here is PDF as scanned and it's paper-based. So you need optical character recognition and structure extraction. So the layout is consistent. So document AI. So you're looking at optical character recognition, right? Which, I mean, the document API does that effectively. You could give it a document and then it extracts it does structure extraction for you. As long as it's consistent, the layout is consistent, so that the document AI tool API will be very, very effective in grabbing the right fields, right? And as opposed to using Vision API, Vision API alone may not extract text, but it may extract text actually, it does extract text actually, but it does not reliably target the comments. You are targeting the comments, right? So it might just extract text for you, but might not target just the comments, the section, because here layout matters. Document API, the document AI will do that effectively, because it will do the structure extraction effectively. This will also extract text, but I mean, we are targeting just the comments, overall score for the customer comments on each form. So there's a structure already. You know, each form has the same layout. So that's what the emphasis is on. Right? So the correct answer here is C. C is the correct answer. So we use the document API, AI custom extractor to pass the comment section, then natural language API to analyze the sentiment. Yes, we already know that natural language API is used to analyze sentiment. So, but the first thing is we need to extract the text first, right, as quickly as possible, and we're just focused on the customer comment section, right? Any question at this point before we proceed? So the next question, we still have a couple of questions before we go to training models, and but let's see if we can. If we look at these three questions more, yeah. So you work for a company that captures live video footage of checkout areas in retail stores. You need to use the live video footage to build a model to detect the number of customers waiting for service in near real time. Right? You want to implement a solution quickly with minimal efforts. So what will you do? Yes. Can you write your suggestions on the charts? We're ending in next 10 minutes. Let's see what we can wrap up, finish by. Try and keep the lessons not more than 1 hour. Yes, so what will be your answer? So remember, it's minimal effort is needed. Near real time is required. Near real time, minimal effort. And you want to detect the number of customers waiting. Remember, I told you there's an API. Google has an API that helps us count number of persons. Yes, so an API that does that. And let's see the API here. So we have there's this occupancy analytics guide. So there's this model that helps us count number of people and vehicles, giving specific inputs you add to the video frames. Right. So this helps us do that. Let's just continue first. And I hope, okay, good. Now, what would be the best option? Use the Vertex AI occupancy analytics model, use Vertex AI vision, person, vehicle. What are we counting? Customers. We are not counting, okay, detector model. Okay, train auto ML detection model on annotated data set. This will be so much work. Train sequence to sequence plus object detection model. I mean, so let's analyze this. So let's go with this first. Person to this Vertex AI vision person to person vehicle might detect people, right? I mean, but occupancy analytics, occupancy, we already seen occupancy analytics. I showed you it's closer to the business metrics. How many people are waiting? Is about occupancy. How many people are occupying the space? How many people are waiting in near real time? Is about occupancy analytics. That's the business need. This would also detect people, but the business need is looking at how many are occupying the space, in near real time. So occupancy analytics, the way I showed you already, is good for counting occupancy style metrics in video streams, right? Yeah. So if you're training auto ML object detection, that will require labeling and training time, and which will conflict with, I mean, you want to implement this quickly. This would require labeling, annotated data set, because you have to label it, right? And it will take time. And so this will not go, and we've already seen why A should be the best. A is the best answer here right now. So you're going to be using the Vertex AI Vision Occupancy Analytics model. All right. Do anyone have any question at this point? So C&D will require training efforts. It's not minimal efforts. So we go with A. Let's see what we have next. Good. Next question. You work at a leading healthcare firm developing state-of-the-art algorithms for various use cases. You have unstructured textual data with custom labels. You need to extract and classify various medical phrases with these labels. Leading healthcare firm developing state-of-the-art algorithm for various cases. You have unstructured text data with custom labels. You have custom labels. You need to extract and classify various medical phrases with these labels. So what do you do? Remember, there are custom labels you have there. So will you use a healthcare natural language API to extract medical entities? Would that just work for you when you have custom labels? Would you use the BERT-based model to fine-tune? You can fine-tune your model. Like I showed you the model I fine-tuned, sentiment analysis model I fine-tuned, and actually a BERT-based model. A medical entity extraction model. Or you want to use AutoML extraction, entity extraction to train a medical entity extraction model. Or, please, let me check the chat. What are we there? Or we want to use TensorFlow to build. This will be so much work again. Okay. Use TensorFlow to build custom medical. So what will you do? What's the best option? Someone says B. Any other suggestion? Why do you think it's B? Okay. It's for the previous question. Okay. Okay. So I want us to suggest, what do you think would be the best option? This will allow, we need to know, are we using AutoML, or should we use train our own bets, or should we, so you can see the pre-trained. This is pre-trained. A is pre-trained actually. B is custom training, right? This AutoML, this is still custom training. So there are three categories here, so the key phrases here is unstructured textual data, and there is custom labels. Now, pre-trained, let's look at A. If pre-trained healthcare can extract standard medical entities, right? But then, I mean, because we have custom labels, this will just give you the standard, entities. All right. Now, you want to so A is good for standard medical entity, right? Not for your custom labels, right? B is possible. B can do the work actually, but then there is so much effort. I mean, fine-tuning a bet-based model is a lot of work, and there's a whole lot of machine learning operations here, and yeah, unless the question demands customization, then if the question doesn't demand customization, avoid anything that will make you use customized stuff, right? Yes. Then TensorFlow, this is from scratch. You're building from scratch. You're using TensorFlow to build a custom. This is from scratch. This is like a whole lot of effort. This is even fine-tuning. It's still custom, but then it's fine-tuning. You're using an existing model and then fine-tuning it, changing the weights of the model. Here, you're building from scratch. This will not give you a custom. So we are left with option C that will allow us to use AutoML entity extraction to train our extraction model. All right. So AutoML entity extraction is used for it highlights spans of text and tag them with the labels you define. All right. So that matches exactly what, so that would do what? To extract and classify the medical phrases with custom labels. So this is AutoML entity extraction. C. Right? Any comment at this point? Let's see. I just want us to finish. So we'll take this last question and wrap it up. So that when we come the next time, we'll start with training models. And but let's just finish this last question right now. So seeing the last question is question Our right answer here is C. And so let's move to the next. So, sample question 97. You work for a pet food company that manages online. So you work for a pet food company that manages online forum. Customers upload photos of their pets on the forum. Oh, hold on, excuse me. Can you still hear me? Okay, good. Let's continue. So you work for a pet food company that manages online forum. Customers upload photos of their pets on the forum to share with others. About 20 photos are uploaded daily. You want to automatically, in near real time, detect whether each uploaded photo has an animal. This is we're detecting, right? Static, in real time. Want to prioritize time, minimize cost of your application development. You don't want to do so much effort. That's why I want to minimize cost of application development. What should you do? Okay. Do you want to send user submitted images to the Cloud Vision API, then use object localization to identify objects in the image and compare the results against a list of animals? Or do we download the object detection model from TensorFlow Hub? Why should we do that? Deploy the model developed AI endpoint. There's so much effort, right? So, or do we manually label previous submitted images with bounding boxes around animals? This is so much work. Do you want to manually? Oh, sorry. Oh, all right. Let's look at these options. So only 20 photos a day, is not much, right? It's not much. That's tiny volume. So you can see, remember this scope. Don't forget this. When you have, when data set is size of the data set, small to medium to large, no data required, and don't forget that. Anyway, let's continue. So we are here, right? Good. And so the question here prioritizes the time and cost of development. Cost of development and deployment. You don't want to waste time, prioritize this time, right? So, a hosted API call will be faster than building and hosting a model endpoint. Object localization returns detected objects. So you just check whether an object label is an animal type. So this will be the very fastest way. So B, let's look at B and see. Deploying TensorFlow Hub, adds endpoint costs, and the machine learning operation is overhead. It will be very high. There's so much machine learning overhead to deploying a TensorFlow Hub, right? That'll be so much. Then C and D is manual labeling, very unnecessary, for a simple if there's animal check, if there's animal or there's no animal, right? So, all right. So, but if the question, if the forum has, remember, if this is just 20 photos, right? What if it's 2 million images per day? Can we still use the Vision API as the best option? All right, you can see that it might change. Yeah. So, but 20 is okay. I mean, this will do the job effectively. So the best option here is A. All right. So we're going to be stopping here so that when we come to the next week, we start with training models. We'll look at how Vertex AI fits into the machine learning workflow. We'll still look at these various options, look at BigQuery ML, and we look at, you know, how BigQuery ML model is supported and these features, various features, the different models it supports, algorithms that supports BigQuery ML. And yeah, then we answer some questions and then we look at BigQuery, AutoML, and custom training. There's still a lot to look at to cover for lesson 3. But just let's come back next week and see whether we can cover the remaining of lesson 3, right? So there's a whole lot to cover, all right? So, all right. So, any question at this point before we call it a day? Right. Thank you for the class. Thank you. Thank you. Thank you for your feedback. All right. So, we call it a day. I want to stop the recording right now. Thank you very much. See you next week. Bye-bye. All right.